So it's similar to the one we saw before. Said the relative maximum of the function f of s is equals to this. So we just find like the relative maximum using the same method we used in the other one. But then this one will actually be for the maximum value, no longer the lesser value as the minimum value. So now, step one, we are going to find f prime of x that will help us to get what we call the critical values. So we're finding f prime of x in this step one. F prime of x is equals to, that's to differentiate this now, this function, that's what f prime of x means. 3 will come to the front as usual. We have x squared over 3, then minus 2 bracket x over 2. This is the constant, it becomes 0. We don't need to write it. 3 will cancel 3, 2 will cancel 2. X squared minus x. In our step 2, we have to equate this into 0. So we equate f prime of x to 0. That means x squared minus x is equals to 0. Because this is actually f prime of x, what we solved initially. So we can solve this equation now to get the critical values or points by saying bring out x, one s is left here. When s cancel s, you have 1 equals to 0. So s is either equals to 0 or s minus 1 is equals to what? 0. Implying that s is equals to 0 or s is equals to 1. 1 minus 1 goes this way. So s either equals to 0 or s equals to 1. So we'll go to test it and test it in the second derivative, which we'll obtain in step 3. We'll find f prime prime of x. So f prime of s is differentiating this again the second time. 2 will come to the front. You have 2x. When you remove 1 from here, you have just 2x. Then minus this s now will give you 1. Because 1 minus 1 is 0. And anything is 0 is 1. So you're multiplying it by 1 as well, so it's just 1. So at s equals to 0, f prime prime of 0 is equals to 2 bracket 0 minus 1, and this is equals to minus 1. At s equals to 1, this one now 1, f prime prime of 1 is equals to 2, that's this 2 now, bracket s which is 1 minus 1 equals to 1. Now this is greater than 0, and this is less than what? 0. The one less than gives us the maximum value. So the maximum value occurred at s equals to 1. At s equals to 1, maximum value f of 1 now, we'll go to the main function, equals to 1 cubed over 3 minus 1 squared over 2 plus 5 equals to 1 over 3 minus 1 over 2 plus 5. LCM is 6 again. This is 2. When 3 divides 6 is 2. Minus 2 divides 6 is what? 3. There's 1 here. 1 divides 6 is what? 6. Plus 6 times 5 is what? 30. 2 minus 3 is minus 1. Minus 1 plus 30 is 29 over 6. So this is the maximum value of the function f of x. And the point at which it occurs is s equals to 1. So the relative maximum point is 1, 29 over 6.